Hi, in this lesson, we're looking at right triangle trigonometry. We're going to look at how to solve right triangles using sine, cosine, and tangent. We'll be able to apply that trigonometry to real-world problems, including bearings and directions problems. And we're also going to look at problems that involve angle of elevation and depression problems. So quite a bit, but hopefully some of this is familiar to you from Algebra 2. So let's get started. First of all, we're looking at the vocabulary when we're talking about a right triangle. If we were, for example, to say that we were focused on this angle right here, from this angle, we have this side is adjacent, this is opposite, and of course the hypotenuse is always across from the right angle. Now, if I were to change it, if I were to say that my angle of perspective is right here, then this would be my adjacent side, and this would be my opposite side. Just so you know, it depends on the perspective. It depends on which acute angle in the right triangle we're talking about. And then we can either find the sine, cosine, or tangent, and there's a little acronym that we use called SOHCAHTOA, and that just reminds you that the sine is opposite over hypotenuse, cosine is CA, adjacent over hypotenuse, and tangent is TOA, opposite over adjacent. So SOHCAHTOA is a reminder of how we would set up the ratios for sine, cosine, and tangent in a right triangle. Okay, so let's take a look at an example. It says use the given triangle to find the exact values of sine, cosine, and tangent. All right, so we're looking at theta, so our perspective is here. The hypotenuse is always across from the right angle, so this is our hypotenuse. The side next to our angle is the adjacent side, and the side opposite our angle, so we're across the triangle, opposite that angle, that's going to be right here. All right, so we want to look at sine, cosine, and tangent. And as a reminder, we could just do the acronym SOHCAHTOA. We know that sine is O over H. We know that cosine, CA, is A over H. And we know that the tangent of theta, TOA, is opposite over adjacent. So in this triangle, opposite over the hypotenuse would be 4, and we don't have the value of the hypotenuse, so we have to figure that out. Now, I know that we have a 3, 4, 5 triangle, but if you didn't remember that it's a 3, 4, 5 triangle, you could use the Pythagorean Theorem. So it would say that 3 squared plus 4 squared equals the hypotenuse squared. Okay, so H is equal to 5. So this is 5. Right, so the sine in this case is going to be opposite over hypotenuse, so it's going to be 4 over 5. The cosine is going to be adjacent over hypotenuse, so that's going to be 3 over 5. And the tangent is going to be the opposite over the adjacent, so 4 over 3. All right, so we have found the exact values for sine, cosine, and tangent. Now, those are just the ratios. If we wanted to actually find the angle, whenever we're finding an angle, we would take the inverse of any one of those to find the angle. But we're going to stick with just finding the ratios for right now. All right, in example 2, again, we're being asked to find the ratios, but this time we don't have the triangle set up, so we have to draw it. We have triangle DEF, and we know that angle D is the right angle. And then we also know that the ratio for the tangent is 3 over 4. So that's a lot of information. Let's just first sketch a right triangle. And the only thing we really know for sure is that the right angle happens at D. So I'm going to call this DEF. And you could have gone the other way. You could have made this E and this F. I don't know, just felt like going the way I did. Now, we know that the tangent of E is 3 over 4. So let's just make a note here. First of all, this is the hypotenuse. If we're talking about this acute angle as our reference point, all right? The side opposite E is here, and the side adjacent E is here. Now, we know that the tangent is equal to O over A. It's TOA, and they're telling us that it's 3 over 4. So from E, opposite is equal to 3. And from E, again, as my perspective, A, the adjacent side, the side next to angle E, is 4. All right, and we could use the Pythagorean theorem to find letter H, to find the hypotenuse. And of course, this is another 3, 4, 5 triangle, so I'm just going to say that this is 5. But again, if you didn't remember that, you would just use the Pythagorean theorem. So we've drawn the diagram, and now we're going to find the exact value of sine. So the sine of E is going to be equal to O over H. So in this case, we have O is 3 and H is 5. So the ratio of sine here is 3 over 5. Okay, moving on. If you are given the measures of an acute angle and the side of a right triangle, you can find the length of another side of the triangle. So let's read this first example. In a right triangle, the length of the leg opposite the 5-degree angle is 3 feet. Find the length of the leg adjacent to the 5-degree angle, round to the nearest tenth. All right, so first of all, let's sketch out this triangle. And we know that we have a very, very small angle of 5 degrees. So this is 5 degrees. And we know that the leg opposite the 5-degree angle, so the leg opposite it, is going to be 3 feet. And we know it's a leg. It's not the hypotenuse. It's going to be the leg opposite that angle. So this one's going to be 3 feet. Find the length of the leg adjacent. So the leg adjacent is the one right next to the angle. That's not the hypotenuse. So we want to find that value. So let's just call that x. All right, now we're going to set up a ratio. Now, let's just note what we have here. We have the opposite side. We have the adjacent side. We don't have the hypotenuse. We don't know what that value is. So we can't use anything that has the hypotenuse in it. So we have, our acronym here, SOHCAHTOA. Well, we can see that the sine would use the hypotenuse. The cosine uses the hypotenuse. So we have to use tangent. All right, so the tangent of 5 degrees is equal to O over A, TOA. O is 3 and A is x. And we want to solve for x. So the first thing I would suggest doing is cross multiply. So we're going to get x tangent of 5 degrees is equal to 3. And now we need to solve for x, so we're going to divide both sides by the tangent of 5. So we're going to get x equals 3 divided by the tangent of 5 degrees. All right, and we want to put that in our calculator, and we're going to round our answer, it says, to the nearest tenth. So let's do that next. All right, so the first thing we want to do here is we want to make sure we're in degree mode, and you can see at the top of my screen it says degree mode. If you're not sure, you can go to the mode button. It's highlighted in red, and you're going to just look down and you're going to make sure that we have the word degree highlighted. You're going to highlight it and hit enter. And then we can do second mode to quit out of there. And so now we're going to type in 3 divided by the tangent of 5 degrees. And we're going to get 34.3 rounded to the nearest tenth. All right, to find the measure of an acute angle in a right triangle, when you're given 2 sides, you can use the inverses of trig functions using your calculator. Okay, I talked about that a little bit at the beginning of the lesson. So it says use a trig ratio to find the measure of angle A to the nearest tenth of a degree. So we want to be in degree mode, and we want to set up our ratio. And we're trying to find letter A. All right. Now, across from A is here, opposite here, next to A, the leg that A can touch is adjacent. All right, so next to A is the adjacent side. So we are seeing here that we're using O and A again. All right, so let's just make a note here. SOHCAHTOA. So which trig function uses O and A? The tangent uses O and A. So we wouldn't be able to use these guys because we don't have the hypotenuse unless we want to take the time to find the hypotenuse using the Pythagorean theorem, which I don't. I'm going to just use the tangent. All right, so we know that the tangent of A is equal to O over A, right? Opposite side is 7. The adjacent side is 4. And we need to take the inverse tangent now to solve for letter A. In other words, we're going to take the inverse tangent of both sides, because if I do that, I'm going to be left with just A on the left side, and I'm going to have to find the inverse tangent of 7/4. That inverse tangent undoes the tangent, leaving me with just A on the left side. All right, so let's do that in our calculator. Now you'll see right above the tangent button is the inverse tangent. So we're going to do second tangent to get to the inverse function, and then we'll enter 7 divided by 4. All right, and we're going to round that to the nearest tenth, so we get 60.3 degrees. All right, and they told us that we would be expecting degree mode, so we have to make sure the calculator is set for that. All right, moving on to example 5. This time we are not given the triangle. We have to draw the triangle. And it's triangle DEF. Angle F is a right angle. They're giving us sides F and E. And I know that they're sides because they're both lowercase, right? Whenever we have lowercase letters, they're referring to a side. Capital letters refer to angles. And we're being asked to find the measure of angle D to the nearest tenth of a degree. So let's draw the triangle first. It doesn't really matter. It doesn't have to be scale to scale. All right, we know that angle F is the right angle in this triangle. And we know that it's called DEF. So I'm going to call it DEF. Across from angle D is side D. Across from angle F is side F, and across from angle E is side E. Okay, now we're going to label up the given information. So we know that F is 13. Based on this guy right here, we know that E is 5. We're being asked to find the measure of angle D. Right, so this is my perspective. Right, if D is my acute angle of perspective, then we know that this is adjacent, this side would be opposite, and of course the hypotenuse is always directly across from the right angle. So I'm going to need to use the trig function that uses A and H. So again, it might be helpful for us to write out SOHCAHTOA. So I need A and H. I need A and H. Cosine uses A and H, so we're not going to use tangent, we're not going to use sine. So the cosine of D is equal to the adjacent side, which is 5, over the hypotenuse, which is 13. We're trying to find an angle. Whenever we're finding an angle, we're going to use the inverse trig function. So we're going to take the inverse cosine of both sides. That's going to leave me with just D on the left side. And it's going to leave me with the inverse cosine of 5 over 13 on the right side, which now I would put in my calculator. So we're going to do second cosine to get the inverse cosine. 5 divided by 13. And we're rounding to the nearest tenth, so we have 67.4 degrees. So D is approximately 67.4 degrees. Okay, moving on to the next page. Now here we're going to be talking about the angle of elevation and the angle of depression. The angle of elevation is the angle that we're looking up at. The angle of depression is the angle down from the horizontal. All right, so it says a tree casts a shadow of 10 meters when the sun is at an angle of 40 degrees to the ground. How tall is the tree? Okay, so let's draw a little picture of this. Have my tree here. Here's my triangle. A tree casts a shadow of 10 meters. So this distance from here to here is the length of the shadow. It's 10 meters. When the sun is at an angle of 40 degrees, now keep in mind the sun is up in the sky. All right, so here's the sun shining down and causing the shadow. And that's causing an angle of depression. So we're looking down. Now the angle of depression, and this is a little tricky, the angle of depression is the angle from the horizontal. So in this case, this 40-degree angle is right here. Okay, now if you remember that when we have parallel lines, alternate interior angles are congruent, you would know right away that that means that this is 40 degrees. This is a 90-degree angle right here. So we would also be able to acknowledge that this was 50 degrees. And the sum of the angles of any triangle is going to be 180 degrees. So 50 plus 90 plus 40 would give me 180 degrees. All right, so that one, those are always a little tricky. Remember that angle of depression is the angle down from the horizontal. All right, now we have the easy part. We just want to know how tall is the tree. I'm going to call this T for tree, right? And then we're just going to pick our angle that we're going to use as our angle of perspective. I'm going to use 40 degrees. So across from 40, that's on the opposite, and the 10 is adjacent. And I don't have the value of my hypotenuse. So I need to pick the trig function that's going to use O and A. So again, we can just write it out. SOHCAHTOA. Which one is going to use O and A? The tangent. So I know that I'm not going to use either of these. All right, so in this case, the tangent of 40 degrees is equal to the opposite over the adjacent. So 10, if I cross multiply now, 10 tangent 40 degrees is equal to T. And we put that in our calculator. And we get 8.39 rounded to the nearest hundredth. It doesn't say where to round. I'm going to just round to the nearest hundredth. So that's 8.39 meters. Okay, moving on to the next one. Michael is flying a kite. The kite string is at an angle of elevation of 60 degrees. If Michael is standing 30 meters from the point on the ground directly below the kite, find the length of the kite string. Okay, so this time we're looking up. We're looking for our angle of elevation. So we have somebody, we'll draw Michael here. And he's got this kite string. Here's our kite up here. Okay, so let's read the problem again. Michael is flying a kite. The kite string is at an angle of elevation of 60 degrees. So looking up at the kite, it's 60 degrees. If Michael is standing 30 meters from the point on the ground directly below the kite, so from here to here, it's 30 meters. We want to know the length of the kite string. Okay, so we want to know This time we want to know this value here. I'm going to call this x. All right. So if we were to set up now what we have, let's see, across from the 60-degree angle, the opposite side is here. The adjacent side is here. And the hypotenuse is always across from the right angle. So what do we want to use? Well, we want to find x. So we know we want to use hypotenuse. And we have the adjacent side. So we're going to use whatever trig function uses a and h. So the trig function that uses a and h is cosine. So we're going to use the cosine of 60 degrees is equal to the adjacent side over the hypotenuse, which we're calling x, cross multiply. Divide both sides by cosine of 60. And we'll put that in our calculator. And we're going to get 60 meters exactly. So the length of the string is 60 meters exactly. All right, moving on to bearings problems. So the bearing to a point is the angle measured in a clockwise direction from the north line. Bearing is referencing an angle starting at that line and working its way around clockwise. So for example, if we just have this and nothing else, that's a 0, 0, 0 degree angle. If we're going from here to here, that's a 90 degree angle. It's 180 degrees. Or if we were going to go all the way to here, 270 degrees. Now, something to note, bearings are written as 3-digit angles. So let's write that down. Also, a bearing tells you which way you're heading. If we have the bearing of P is 0, 65 degrees, that's going to be this one right here in red. And if we have the bearing of Q is 300 degrees, that means we're going to, again, start at the north line, go all the way to 300. And what would be remaining here would be 60 degrees. Remember, all the way around is 360 degrees. All right, so let's look at example 8 here. Nina runs 5 kilometers on a bearing of 120 degrees from the start. How far south has she traveled? Okay, so let's do a diagram. First of all, we're going to do a quick little sketch over here just to get the direction that Nina is going. Remember, this is north at the top, south on the bottom, west and east. And we're being told that she's going on a bearing of 120 degrees. Well, she's starting at the north line, and she's not quite going to 180 degrees. So she's going to be in that fourth quadrant. So let's draw that. Okay, so that's a bearing of 120 degrees. And just to note here that, from here to here is 60. This diagram is not to scale. All right, now we know that she runs on that bearing for 5 kilometers. So what I like to do is just kind of extend this line now that we drew. And we're saying that this is where she starts. She's going on this bearing, right? This is where she starts, and this is the direction she's heading. All right, we're going to say that this is where she ends. We'll call that Nina 1, Nina 2. And now we can draw our triangle. It's starting to come together a little bit here. She's running 5 kilometers on that bearing. How far south has she traveled? So I want to know this value here. I'll call this x. This is the distance. This side over here is the distance south, in the south direction she's traveled overall. And I already know, that this is 60 degrees, right? We have that marked right here. So this angle is 60 degrees. So now we have enough information to solve for x. We just have to pick the correct trig function that goes with it. So let's just mark it up here. If my angle of perspective is 60 degrees, this is the side adjacent to 60, and this is the hypotenuse. So I need the trig function that uses a and h. So that would be cosine, ca. So the cosine of 60 degrees is equal to the adjacent, we're calling that x, over the hypotenuse, which is 5, cross multiply. So we get 5 cosine 60 degrees equals x. Put that in our calculator. And we get 2.5 kilometers. So x is equal to 2.5 kilometers. All right, now these problems, they're a little tricky. You have to be really awake and ready to go. So we're going to try another one. The next one's a little bit harder too. So see how this goes. Let's read it first. A boat is due south of a lighthouse and sails on a bearing of 292 degrees for 51 kilometers until it is due west of the lighthouse. How far away is it from the lighthouse now? Now, I don't know about you, but I wouldn't know where to begin this problem unless I did a really good diagram. So we are going to make the best diagram we can. So first of all, let's draw our north, south, east, and west diagram. That's going to help us. And we know that we're sailing on a bearing of 292 degrees. Well, 292 degrees is past, here's 90, here's 180, here's 270. So we know it's going to be in this second quadrant here, and it's 22 degrees past 270 degrees. So I know that angle that I'm going to draw is going to be about 22 degrees right here, because if we do 292 minus 270, remember, this is 0, this is 90, this is 180, and then this is 270, considering we're following a bearing. 292 minus 270 gives me 22 degrees. So my bearing is all the way to here. So that's the directional line that I'm following. So this is my bearing line right here. So that's the bearing part of the problem. So now we have to draw the rest of it. All right, now we know that we have a boat and it's due south of a lighthouse, sailing on that bearing, and it's sailing on that bearing for 51 kilometers until it is due west of the lighthouse. Now I'm still a little confused, but I know that it's sailing on a bearing of 51. So what I'm going to do, I'm going to draw the next part of this where I'm just sort of marking up this bearing. All right, so this is where my boat starts. I'll call that B sub 1. And then this is where my boat ends. Okay, I'll call that B sub 2. All right. So we have that part. So the boat is due south of a lighthouse. Now, from here to here, this is south. Just like in this problem, this was my south line. This is my south line. So the boat is due south of a lighthouse when it starts. So let's draw a little lighthouse into our picture here. So this is where our lighthouse is. All right, so the boat is due south of a lighthouse. So we've taken care of this. Sails on a bearing of 292 for 51 kilometers. So it's sailing on this bearing for 51 kilometers until it is west, until it's over here of the lighthouse. How far away is it from the lighthouse now? So we want to know this value here. What is the distance that the boat is from the lighthouse after going 51 kilometers? There was a lot to that problem. All right, now we know that we have a 22-degree value here, okay? And then this measure here, well, that's going to be 90 minus 22. So that measure there is going to be 68 degrees. So we know 68 degrees goes here. All right, so we have our picture all set up and ready to use our trig. So from 68 degrees, we know that we're going to be using the hypotenuse, and we're going to be using the side opposite. So opposite and hypotenuse, that means that we're going to use the trig function sine. Sine of 68 degrees is equal to the opposite over the hypotenuse. We're going to cross multiply, so we're going to get x equals 51, the sine of 68 degrees. And if we put that in our calculator, we'll get x is approximately 47.3 kilometers. Now, for our purposes, this was a really hard problem, and I promise they won't get any harder than this, but this is an accurate level of difficulty for the IB exam. So if you really struggled with this problem, even while I was explaining it the first time, I would suggest probably pausing and just listening to me explain the problem again, like listen to it, maybe another time. That would really help, I'm sure. Okay, and of course, we can do any of this live in class. All right, so last page here, direction. Now, the direction to a point is stated as the number of degrees east or west of a north or south line. So I have some examples here. So point A we would say is north 30 degrees east. So the first letter tells you where we're starting. We're starting north and we're going east. So we're going this way. For letter B, we're starting north and we're going 60 degrees west. Starting north, going west. For letter C, we are starting south and going 70 degrees east. That would be C. And then for letter D, we're starting south, but we're going west. So that's going to be 80 degrees. All right, so it's another way of providing you with a direction. So we have a boat travels on a bearing of south 30 degrees east. So they're going south 30 degrees. All right, so we're going to just mark that up, that this is 30 degrees. And it's going on that bearing for 10 meters. So let's just draw in a right triangle here. All right, it's starting here and it's going to here. We call this B1, we call this B2. It's traveling for 10 meters. Now that 30 degrees is outside our right triangle. We always draw our triangles to the x-axis, to the east or west line. And if this part here is 30 degrees, then we know that this angle has to be 60 because those two angles form a right angle. So this is going to be 60 degrees. We want to know, letter A, how many miles south has the boat traveled? So the south value is going to be this line here, right? That's south. And part B is asking us how many miles east. This is the east line. How many miles east have we gone? So I'm going to call this letter S, and I'm going to call this letter E. And now I'm going to use different trig functions to find both of those. Let's mark up what we have here. Across from 60 degrees, this is our opposite side. This is our hypotenuse, and this is adjacent. So for south, I want to use opposite and hypotenuse. So in that case, I'm going to be using sine. So the sine of 60 degrees is equal to the opposite side, which I'm calling S, over 10. And now I'm going to solve for sine of 60 degrees. So cross multiply. So 10 sine 60 degrees equals S. If we put that in our calculator, we'll get that S is approximately 8.66 meters south. For part B, we want to find letter E. We want to find how many miles east has the boat traveled. In this case, we're going to be using adjacent and hypotenuse. That means we're going to use cosine. So the cosine of 60 degrees is equal to the letter E over the hypotenuse, adjacent over the hypotenuse, cross multiply. So 10 cosine 60 degrees equals E. So if we put that in our calculator, we're going to get E is equal to 5 meters east. Okay, there was a lot in this lesson. Thank you for watching it to the end. Plenty of more practice. Don't worry, more practice is going to make perfect. Have a great day.